Maxima Hunter right there. Right out of the package, right out of the box. We're gonna take them over to the lab.
Okay, 101.
These are the tri-spine ones. So we got the tri-spine, the dual spine, take one shaft out of there at random. I'm gonna measure the full length of the shaft. Take 32.5 inches. So I'm gonna make my mark and my cut at 16.25 inches on this shaft. Right, so I'm over here at the arrow saw now with the Maxima Hunter, a dual spine weight forward technology arrow shaft. I've already set the saw at a predetermined length to cut this arrow in exactly 2 equal parts. Anytime you're going to use an arrow saw, just take in some safety factors. I've got my glasses, I've got my mask, and we've got a filtration system here. So let's cut this arrow. Now we've got this arrow shaft cut in half. We've got 2 equal sections, both at 16.25 inches. I'm going to take them over to the scale and have Alex put them on there and validate the dual spine weight forward technology. So here's the 2 halves of the arrow shaft, Alex.
Thank you, Dave. So we'll go ahead and start with the rear section. This is a blank shaft, 125 grains.
And that's the back of the arrow, right?
Back of the arrow. Moving to the front section, 126.6. So you're going to see a slight weight forward in this test right here that Dave's come up with and shown you. A better way to show this, though, is to actually show your grains per inch. What you're doing when you weigh these 2 sections is a couple things. So this arrow is 3 sections. The front 2 sections are the exact same. So what is happening is you're actually getting some of that heavier front section being weighed out in the back half. So as well as 5 grains.
The logo on there
on the heat transfer label. That's
so
5
my
grains.
method, although simple, not really getting to the science of it.
Nope. I mean, you showed. You proved weight forward in a blank shaft right there, but
And it
it's
looks
more
pretty
powerful than that.
minimal when we do that. So if we were to break this down into more sections like you're showing, we should see a more substantial difference in the gain in grains per inch.
Absolutely. And I've already done that. So we can take a look at this Maxima Hunter 250 right here. So I've got a rear section and a front section already cut out. They're measured to precisely 1 inch. So the rear section of that Maxima Hunter, 7.2 grains. Grabbing the front portion of that Maxima Hunter, we've got 7.4 grains. So
we've got
0.2 grains.
A 0.2 of a grain per inch gain as we move forward.
Yep.
And if we were to look at further sections of the arrow, closer where the insert and point would go, we should see that increase substantially.
Absolutely.
Right?
Yep.
That's definitely a lot more precise than what I was looking at.
Yeah, agreed. Yep. We can show you the same thing on this Maxima Red here, which is a tri-spine arrow. So we'll go ahead and grab the rear portion. We've got 7.8 grains on that rear portion. Middle portion, we've got 8.2 grains. So you're seeing the start of the
That's an
the
even
weight
bigger
forward.
increase than
Yep.
as far as percentage compared to that Maxima Hunter.
Yeah, the Maxima Red has a really good weight forward built into it.
What's the last section look like? The front?
Even heavier. 8.4 grains.
8.4.
So you're seeing a steady 7.8, 8.2, 8.4.
A fairly substantial increase in grains per inch.
Yep, absolutely.
Well, that's definitely a better way to do it than I did. I kind of went out the junk science way. It's like, well, I know I got an arrow, and if I cut it in 2 equal parts, I should see a difference. And I did.
And you did.
But when we break it down and look at the science into it and really get down to what the GPI is, the grains per inch, which is like one of those most important, specs that we look at when we're selecting arrows. Well, I want to shoot this many GPI for a hunting arrow or a target arrow. It's actually a better way to do it. So
Absolutely.
thanks for taking the time to walk us through that in a lot more scientific way.
Absolutely. Happy to do it, guys. Thanks.
So we come over here to another section of the Carbon Express testing lab, and we're actually going to look at some spine values, and we're going to demonstrate multi-spine technology within a parallel shaft. Now, I want to have Alex explain to us a little bit about this piece of equipment we're using here, because this doesn't look like your average spine tester.
No.
This looks pretty high tech.
It certainly is, yep. This is a scan micrometer. It reads more accurate than anything else out there.
How many decimal places are we looking at measuring at here?
5.
5 decimal places.
5.
And most spine values you see published only go to how many decimal places? 3, isn't it?
Yep.
So we have the capability to measure beyond that. And as you can see, the fluctuation in the gauge probably just has a lot to do with the atmosphere, with the fact we're touching the table.
Yep.
We're even in here on the floor.
Yep,
And it's
it's
mounted on
extremely accurate.
a piece of engineering granite that's been milled to be perfectly flat
Yep.
and very, very stable surface. So
Within a half hour.
this isn't like putting a RAM spine tester on your kitchen table.
It is not, no.
All right.
No, not at all. So this thing, incredibly tight tolerances. What it's going to show us, what we're going to do with it today, it's got multiple functions, but we're going to be able to show you the differences in deflection from the middle to the back to the front part of the arrows to validate that dual spine, tri-spine, multi-spine construction.
Great. Well, let's start with that Maxima 100, the
Okay.
dual spine, just to kind of make that first measurement a little bit
Yeah.
simpler so we can follow everything along. And when Alex does this, he uses a gauge in there to put the weight at a specific amount away from the clamp, the pinch point, so that it's consistent through the entire process. And the front of that arrow is going to come in at about 157.
Okay.
Now we'll take the arrow out of the clamp and we'll flip it around end for end to isolate and measure just the rear section of it.
You got it. Again, zero that out.
Gauge is zeroed, spacers installed so the weight's placed at the same distance from the pinch point on the shaft for both the front and the back. $139.
139. So what that's showing you is 139 in the back, 157 in the front, shows more flex in the front of that arrow and a stiffer rear portion of that arrow.
Yeah, precisely what you want on a hunting arrow. You want
Absolutely.
to keep those fletchings and broadheads aligned, allow the arrow to flex where it needs to flex. That's a dual spine. Let's take a look at a tri-spine.
Got a Maxima red here, be a perfect example. So again, we will start with the front. Stable now.
116.
Yep, 116. The front section there, 116. We'll jot that down real quick.
It makes all this more difficult when you have a piece of equipment that's actually a lot more precise than your average
Yep.
spine tester, doesn't it?
Yep, it takes a little bit longer for everything to stable out and get you that exact number, but the accuracy of it can't be.
The level of precision's unmatched.
Yep.
I mean, you can't compete with this with a conventional spine tester on your kitchen table to try to validate technical results like this.
Checking out the middle portion here.
Which we can already see is
Yeah.
weaker
Yep.
by, so that's coming in at 124.
$124.
Now we'll take the arrow shaft out of the clamp, flip it end for end, and measure just the rear section. Instead of sliding it forward and then having all the weight of that arrow on there to skew the results, it's all about consistency. And there we got the back section of that arrow coming in at 120 thousandths of deflection.
Yep.
Utilizing the test. So here you can see with the numbers, we already talked about the dual spine. Here's the tri-spine. We've got 116, 124, 120.
Yep.
Therefore, pushing that energy towards that path of least resistance and creating a hinge point, like we talked about with the other arrow,
Yep.
for more accuracy, better broadhead stability, and a more forgiving arrow.
Yep.
For
Yeah,
hunting
what this
purposes.
tri-spine is able to do is harness all of that flex to the middle section being the weakest section. And we're able to prove that right there.